IPL Database Management System, and I am myself Deepa, and my teammates are Akshata, Deepa, Durga, and welcome to my presentation on IPL Database Management System. In this project, I have designed a IPL Database Management System where we store, analyze, and data related to team, stadium, players, matches, auction, performance. And the primary goal is to build the relational database model that can answer IPL analytical queries like retention, player performance, winning, stats, and so on. And why IPL database means IPL generates the massive data every season, and there are multiple aspects: team management, players, auction, records, match results, like etc. So manual managing these data is too difficult. So, using proper designed relational database system, we can store, retrieve, and analyze the IPL data efficiently. So, we use the data management system, and uh, let us come to the conceptual schema, entity, and attributes. Team entity. In team entity, there is a team ID is the primary key. Means it is the unique ID of the team, and team name is the name of the team owner, with who is leading the team or who owned the team. City and coach are name of the team and coach, like that. And in the second entity, player ID is the primary key, means that is the unique ID of the each player, and player name is the name of the player, and role is role as a batsman, bowler, all-rounder, wicket keeper, like that. And nationality means which country the player belongs to, and date of birth of the player. And third entity is the match ID is the primary key in the match, and match date, on which date match is going on. And stadium ID is the foreign key means are a duplicate of primary key, means we are taking that unique ID to the some other table, like that. And team ID 1 and 2 also like foreign key, and we are duplicating that key. Also winner team ID also. And highest score player ID is a foreign key, which is duplicated by the player ID. And auction is the fourth entity of the database management system, and auction ID is the primary key, and the player ID, team ID is the foreign key, means we are referring that unique ID, we are taking that ID, like that. And season year is the when the auction is taking on which match, like that. Price and return is like that. Stadium is the fifth entity, and stadium is the primary key, and name, city, stadium capacity is all belongs to the stadium. And performance is the sixth entity and final entity of the of the database. And the performance ID is the primary key, and match player is the foreign key, means same, duplicating the primary values. And runs, wicket, sixes, and strike rate, economic rate, all belongs to the match. And this is the ER diagram. In this ER diagram, we can see the player is auctioned to the multiple teams. Like here, see, we can see how the auction and player are related, like that. And player plays for multiple teams in a different season. Means player is related to the means player plays the team every year, like that. One match is played in one stadium, means stadium is related to player. Match means in one stadium matches are many, like that. Multiple performance are recorded for each match. And auction table handles multiple season retention, price, and player team relationships. And also it is here we can see it, team, player, match, performance, stadium, auction are the main entities, and these are the attribute of that entities. And this is the works on, means what function it has to be performed, like that. This simple represent that. And these are the cardinalities. And let me see the what is relational cardinalities also. Then see, these are the relationship cardinalities: player and auction. See here, player and auction both are related to many, right? So we can see many to many, and a player can auction to the different team in different season, and a team can bid for multiple players. uh, like that, player team also, player and team also, many to many means team can buy the many players each season, in also in different season also, but each team can have many players, like. And player and performance match, the three of them also related many to many in relational cardinality. And a player can perform in a many matches, and each match includes performance from the many players, like that. And team and matches also related, like many to many cardinality. So each match is between two teams, and each team can play multiple matches. And match and stadium are related many to one. So every play match is held at a one stadium, but stadium can host many matches. uh, Team and player also many to many cardinality. So team can have many players, and players can be part of the different teams in different season. And match performance also related one to many. So one match has many individual players, one per players, like that. But each performance is tied to the only one match. And next part, relational cardinality, is continued by Durga.
Hello everyone, I am Durga and continuing relational schema. Relational schema is team ID, which is related team name, owner, city, coach, and also player ID. Related to player name, role, nationality is date of birth also. Then match ID, match date, stadium ID, team 2 ID, winner team ID, and highest score player ID. Then action ID, player ID, team ID, season, year, prize, retired. Then stadium ID. Stadium ID is related to team ID, which is name, city, capacity. Then performance ID, match ID, player ID, runs, wickets, sixes, strike rate, economy rate. Next slide, ma. Thank you all.
Hello everyone, myself Akshata. I am going to represent a creation table of the. Let us create a table of a team first. The entities are team ID, team name, city, owner, coach. Next, let us create a table of a player, player ID, player name, role, nationality, date of birth. And let us create a table of a match. The entities are match ID, match date, stadium ID, team 1 ID, team 2 ID, winner team, highest score. Next, let us create a table of a stadium. Entities are stadium ID, name, city, capacity. And let us create a table of an auction ID, player ID, team ID, season, year, price, retained. Let us create a table of a performance. The entities are performance ID, match ID, player ID, runs, wicket, sixes, strike rate, economy rate. These are the creation table. Next part is continued by Deepa.
Insert into team. Team ID, team name, city, owner, coach, values. Here, you insert statement is used to add new rows of data into team table. Insert into team tells the database to add data to the team table. Team ID, team name, city, owner, coach specifies the column where you want to put the data. Values provides the actual data for each new row matching the order of the columns you listed. Each of the parentheses is one new row. Next, player data insertion. Insert into player ID, player name, role, nationality, date of birth. This statement adds 5 player records to the player table, including detail like their ID, name, role, nationality, and date of birth. Insert data into stadium. Insert into stadium. Stadium ID, name, city, capacity, values. This statement populates the stadium table with information about 5 different cricket stadiums, including their ID, name, city, and seating capacity. Match data insertion. Insert into match ID, match date, stadium ID, team 2 ID, winner team ID. This statement adds 5 match records to match table detailing the match ID, date, stadium where it was played, the two competing teams and winning teams. Note that team 1 ID, team 2 ID and winner team ID assume corresponding team ID exists in team table which was not provided in your schema. Table into auction. Insert into auction. Auction ID, player ID, team ID, season, year, price, retained. These statements insert 5 records into the auction table, capturing details about player auctions, including the auction ID, player ID, team ID, season, year, price, and whether the player was retained. Insert data into performance. Insert into performance. Performance ID, match ID, player ID, runs, wicket takes, sixes, strike rate, economy rate. These statements add 5 player performance records to the performance table for specific matches, including runs scored, wickets taken, sixes hit, strike rate, and economy rate.
Let us discuss some queries about the IPL Database Management System. And firstly, we are going to explain about which team has won most matches at a particular as a stadium. Okay, then this is the query we have, and this is the solution for that. We let us see what is that query is that. Okay, then here from match M. So we want a how many matches has owned at a particular stadium. No, so this is the stadium name. So we have to take a stadium name. So then we can find the which stadium has taken lots of own matches. Then team ID, how much matches. So we have used the aggregation function count, and from M match M join team on a winner ID means we start from a match table. Every match stores a winner team ID, right? So the team that own the match, we join this to the team table to get the team name of the winner. So we taken like that. Then this help us to which team own the which match. So next stadium join stadium is on stadium ID is equals to stadium ID. Why we use like that means each matches happen at a particular stadium, and the stadium column is match table connects to the stadium table, and this join help us to get the name of the stadium where the match was played, and select. See here again we are explaining like that means why we select the stadium name and team name and count aggregation function. After joining this all, stadium name gives us the stadium name and team name gives us the winning team name. Okay, then count wins has a wins like means counts how many times each team has won at each stadium, and group by the S name. Team name means this group the results for each combination of the stadium and team. Without grouping the count, could not know how to calculate wins per team per stadium. Okay, then order by here. Order by S name wins means the output is first stored by the stadium alphabetically. Inside the each stadium, teams are ordered by numbers of wins in a descending order. So the team with maximum wins at a stadium appears at the top. Then we runs this. Okay, then let me see the output. See, this is the output. These are the stadium, and these are the team names, and it wins at one time. Okay, then next query is executed by Akshata.
Okay, next query is which player has taken the most wicket in IPL history? The query is like this: select p dot player name. Here the select is used, the clause is used is select. This line selects the player's name from the player table and calculates the total number of wickets each player has taken using the sum aggregation function. And p name refers to the name of the player, and pf dot wickets adds up all wicket taken by each player across all the matches, as total wickets gives a readable scores. And from player p, the clause is used is from. This specifies the base table from the query. Next, join performance pf on player id is equals to. Here the clause is used is join on. This joins the player table within the performance table using the common column called player id. uh, this ensures the each player's match wise performance data linked correctly. Next, group by p dot name. The clause is used is group by. The group by explains the groups the result by player name so that the sum function can calculate the total wickets for each player. Next, order by total wickets desk. Here, the clause is used is ordered by. This sorts the players in descending order of total wickets and the highest first. Limit one means here the clause is used is limit. This restricts the output to only the top one results. That is the player with the most wickets. Uh, so let us run this query and see the output. Here we get a player name and the total wickets. Player name, so total wickets are 2. Player name is Maxwell. So next query is executed by Deepa.
What is the average first inning score at a particular ground? Here is the query. Select yes name as stadium name, round average team score dot total runs comma 2. Select. This is the projection clause. You are selecting specific column to display. S name as stadium name retrieves the name of each stadium and renames it to the stadium name. Round average team score dot total runs comma 2 calculates the average total run made in the first innings and rounds it to two decimal places. This is used for analysis of scoring trends. From stadium S. From specifics the base table. You are starting the stadium table as its S. Join match M on S dot stadium ID is equals to M stadium ID. Join combines row from match and stadium where the stadium ID matches. Ellipse connect each match to the stadium where it was played. Join select M match ID sum pf dot runs as total runs. You are now defining a subquery to calculate total runs scored by team 1 in the first innings of each match. Sum pf dot runs adds up all the runs scored by players of team 1 from match M join performance pf on M match id pf dot match id. Match is joined with performance, so we can get stats of each match. Join player P on PF player ID is equals to P dot player ID. Connects performance to the player table to access player details. Join T on T dot team ID is equals to M dot team 1 ID. Connects the matches team first to the team table, ensures the team data is relevant to the first innings, where pf dot player id in select player id from auction where team id is equals to m dot team id, where Clause filters the performances, only consider those players whose player ID appears in the auction table for Team 1. Example, those who were officially part of Team 1. Group by m.matchid as team score on m.matchid is equals to team score dot match id. Group by groups results by each match to get total runs for the match's first innings. The subquery is analyzed as team score, which is the which is then joined back to the main match table, grouped by s dot name. Final grouping by stadium name to calculate average runs per stadium across all matches. Here is the output. Next part is continued by Durga M.
Hello everyone. My query topic is which captain has highest win percentage in IPL history. From auction A, join T on team ID equals to team ID. This means combined data from auction and team tables. Why we use this? Because the auction table shows the team ID, which matches the player was auctions or retired to, and team table was given team name to display. Where we use the A retained is equal to S. This filters only the players who were retained. It ignores players who were newly bought or not retained. Retained column shows either S player retired this season, no means no players are not retired. Group by team, we want to count how many retired players each team has. So we group all retired players according to their respective team name. Count as retired players. This count how many players each team has retired. Count simply counts numbers of rows after grouping. Ordered by retired players best, we sort the teams in described order. Teams which highest number of retired players will appear at the top. Here is the solution is